This is your first quiz of the year, and I'm going to let you in on a well-known secret. When I make a quiz, I use the practice quiz as the template. So what you're looking at right now is the template that I would use to make the version of the quiz you're going to be taking on this section of our unit. So if you can answer question number 1, typically that means you can answer question number 1 on the quiz. All I do is change something around. So for question number 1, it says, what's the total number of nucleons in nickel? On the quiz, I may ask, what is the total number of nucleons in aluminum? So if you can answer this one, you can apply the same concept to question number 1 on the quiz. So it's really important that you understand how to get the correct answer for each of these questions. So watching this practice quiz is going to be super helpful to you. But if you haven't tried it first, you're going to watch this and think, oh yeah, that makes sense. I could probably do that. But you won't really know if you can do it or not. And that's why I ask that you have watched this and attempted the practice quiz before the last day of class, before the quiz. That way you can ask the questions you need to ask in class in order to help you do your best on the quiz the next day. So let's go ahead and do this together. Definitely you're going to need your periodic table. You may also at this point still need table S to look up the symbol that corresponds to the name. I have most of those memorized, so I don't often use table S, and it would really clutter up my page if I pulled that in every time. So I'm going to make the assumption that you know how to look up the name in table S and find the symbol. Then use that symbol or atomic number you can get from table S to find it in the periodic table. So question 1, what is the total number of nucleons in nickel? Before we even look at the periodic table, let's make sure we know what nucleons are. Nucleons are the particles in the nucleus. Those are the protons and the neutrons. The protons and the neutrons are the only things in the atom that have measurable mass. So if you just take your mass and round it to a whole number, you should be able to get the number of nucleons. So let's look at our periodic table and find nickel. Nickel, by the way, is not N, it's Ni, it's right here. And we're going to look at our mass. If you ever forget which number is the mass, you can always look at this key to find that out. So here's our mass, and we round that to a whole number. The whole number would be 59. So that's going to be our number of nucleons. All right, next question. What is the charge on the nucleus of an atom of magnesium? The charge on the nucleus means which particles have a charge in the nucleus and what would that total magnitude be. So we just said in the last question that the things in the nucleus are the protons and the neutrons. Protons have a positive charge. Neutrons have no charge. They have mass but no charge. So essentially if we know our number of protons, we can just put a plus in front of it or behind it. It doesn't matter which way, as long as you assign an actual charge. Whenever we ask for a charge, you have to say plus or minus. In this case, because it's going to be the number of protons, it'll be plus. Now, how do we figure out the number of protons? The number of protons is actually the atomic number. The atomic number is how the elements are arranged in the periodic table, but it's also the number that defines that element. The number of protons defines what element it is. So let's find magnesium, and be careful, magnesium and manganese look very similar. Here's magnesium, and its atomic number is 12. Again, if you forget where the atomic number is, go ahead and use that key in the center of your periodic table. So our number of protons is 12. And since they're positive, we're going to say plus 12. Remember, if it says charge, you need to give a charge. All right, number 3, what is the total number of neutrons in an atom of fluorine? Well, we said that the protons plus the neutrons equals the mass. We also said that the number of protons is the atomic number. So essentially, if we take our atomic number, and we add our number of neutrons, it will give us our mass. So if I wanted to figure out the number of neutrons, I would just subtract the atomic number from the mass. that makes sense, because the atomic number and the number of neutrons equals the mass. So let's find fluorine. Fluorine is over here. It's in group 17. Its mass, rounded to a whole number, would be 19. Its atomic number is 9. So we're going to do 19 minus 9, or 10 neutrons. Number 4, what is the average mass of an atom of boron? And they want us to round to a whole number. So let's find boron. Here's boron here, and we're going to round this to a whole number. We're using the same rules you use in math class. When you round to a whole number, you look at your first decimal place or your tenths. If it's 5 or greater, you're going to round up. If it's 4 or less, you're going to keep it the way it is. So this becomes 11. I'm going to move this up a little bit. How many protons does an atom of aluminum have? And we set up here, the atomic number is the number of protons. So we're going to need to find aluminum in here. Here's aluminum. The atomic number is the bold-faced number below it. So that would be 13. A neutral atom, I don't even really need to say neutral. Whenever I say atom, you can assume that it's neutral. If it wasn't neutral, it wouldn't be an atom, it would be an ion. So an atom of phosphorus contains how many electrons? Well, if you have a certain number of protons, which are positive, you have to have the same number of electrons, which are negative. So they'll cancel each other out and make the net charge 0. So let's find phosphorus. Phosphorus is right here. It's P. Okay, it has an atomic number of 15. Atomic number is the number of protons, so that's how many pluses it must have. So it must have the same number of, why is it doing that? It must have the same number of minuses. So it has 15 electrons as well. What is the charge on a nucleus of iron? So again, we're looking for charge. In the nucleus, the only thing that has a charge, if you recall, are the protons. There's protons and neutrons in the nucleus. Neutrons, as implied by their name, are neutral. Protons are positive. We get our number of protons from the atomic number, so we need to find iron. You're probably going to have to look in Table S for this one. Iron is not I. Iron is Fe right here. And our number of protons is our atomic number, so this will be 26, but recall that we need to put the charge on there as well. All right, next one, we're going to name the following isotope. Whenever we name an isotope, you have to give either the name or the symbol, and you have to give its mass. Because what's special about an isotope is its different mass. So that needs to become part of the name. I probably didn't leave you enough room on the line for number 8 to give the name, so I would give the symbol probably for this one. Now, how are we going to know what element X is? Well, I've given you the atomic number. That atomic number defines the element. So if I just find atomic number 50, here it is right here. SN, by the way, is tin. You can look that up in Table S. But we're going to use the symbol because I haven't left us enough room to write out the name probably. Although tin's only one more letter, so I guess you could. And then we need to give the mass. That's what this upper number is. Tin 130 or SN 130. All right, number 9, name the most common isotope of the element sulfur. Again, they said name. So we have to name it like you would name a normal element or an isotope. So I'm going to actually write out sulfur this time so you can see it both ways. The most common isotope would be the mass from the periodic table rounded to a whole number. So let's find sulfur. Here's sulfur here. Here's its mass, 32.065. And when I look at my tenths place, that tells me I just need to leave that number alone. So it's going to be sulfur 32. All right, number 10, an atom contains 9 protons, 10 neutrons, and 9 electrons. What is the total number of nucleons in this atom? Nucleons are the particles found in the nucleus. Those are the protons and the neutrons. So when I add those together, I get 19. Number 11, how many electrons does copper plus 2 have? Normally, an atom of copper would have the same number of electrons as it has protons. So when we find copper, here's copper, it's element number 29. So normally, copper has 29 pluses, but this time we don't have 29 minuses. We have to end up with 2 pluses left over. So in order for that to happen, we must have 2 less minuses, or 27 electrons. You really don't need the symbol E minus, but I wrote it because it helps me remember. All right, number 12, draw the nuclear model of the atom. This is the one that Rutherford came up with. You should have a small, dense, positively charged nucleus with negative charges around it, and he didn't really define where those were. What were J.J. Thomson's contributions to the atom? Well, he found negative charges. We now know those to be electrons. And if you want to add something else, he described the plum pudding model. Or you could say that he surmised there must also be positive charges. Oh, number 14, who developed the plum pudding model? Probably should have a longer line here. That was Thomson. No P on that. Back. On the back here, you're going to be calculating average isotopic mass. Notice that these questions are worth a lot of points. That's why they're given for 3 questions worth apiece. So you want to be really careful when you do this and make sure when you finish each one that you ask yourself, does this make sense? So what you're going to do is you're going to take the mass you're given and multiply it by the percentage. I don't know what that percent button does on your calculator because it doesn't do what I would expect it to do. So I always move my decimal 2 to the left. You can either do that by drawing in the humps, or you can literally divide by 100 because that's all you're doing. You're removing the percentage by dividing by 100. You got the percentage by multiplying by 100. So that's how you would come up with that decimal. So we're going to do that and multiply it by its mass. And you're going to end up with, and I'm going to write out all the numbers that my calculator gave me. And then we're going to add them up. Now, before I decide that I'm all done and that it makes a lot of sense, I'm going to make sure that it does. So I'm looking back at my masses. I have 85 and 87. Does my mass lie between those? Sure does. Is it closer to the heavier weighted than the other one? And the heavier weighted one was 85. It is closer to 85 than it is to 87. So I feel like this question, or this answer to this question, makes a lot of sense. All right, next one. A lot more work involved here. So we're going to multiply, and we get 31.04. Multiply. Okay, be careful with these ones. Sometimes you have to actually put in a 0 to put in your 2 humps. And this time I have to have 2 zeros in there. And now I just add the whole thing up. 65.405 is what I get. Let me check and see if that makes sense. My numbers line between 64 and 70, so does my answer. My greatest weight out of all of these is the 48%, which is at 64. And this is relatively close to 64. It's not closest to 64 because these other ones actually weighted a little more in the other direction. I think my answer does make sense, so I feel confident that I'm done. Good luck on the quiz. Make sure you ask questions before the quiz if you have any.